theorem says that f of z which is analytic in a closed curve C except at finite number of singular points which lie inside closed curve C will have integral over C f of z dz equal to 2 pi I times sum of residues at the singular points which lie inside C. We have singular points which are points at which f of z fails to be analytic. If f of z has a simple pole at z equals a, then residue of f of a, that is residue of f of z at z equals a, is obtained using the expression limit z tends to a z minus a into f of z. If f of z has pole of order n at z equals a, then residue of f of z at z equals a is obtained by the expression 1 by n minus 1 factorial d raised to n minus 1 upon dz raised to n minus 1 applied on z minus a the whole raised to n into f of z at z equals a. When f of z is of the format phi of z upon psi of z, residue at z equals a for f of z is obtained by evaluating phi of a upon psi dash of a when psi dash of a not equals 0. Let's look at an example. Evaluate integral over c z square dz upon z minus 2 into z plus 3 where c is the closed curve modulus of z equals 4. We obtain poles of the given function by equating denominator to 0. We have z minus 2 into z plus 3 equals 0 give two poles z equals 2 and z equals negative 3. We have these two poles of order 1. Therefore, they are known as simple poles. Since we are having both poles being simple poles, we can make use of the equation residue at z equals a for f of z equals limit z tends to a z minus a into f of z. Here we have to give z equals 2 and z equals negative 3. Residue of f of z at z equals 2 is obtained as limit z tends to 2 z minus 2 into z square upon z minus 2 into z plus 3. Cancelling z minus 2 from numerator and denominator, we get z square upon z plus 3 and we give limit z tends to 2 and we get final answer as 4 by 5 which is the residue of f of z at z equals 2. Similarly, residue of f of z at z equals negative 3 is obtained using the same formula. Limit z tends to negative 3 z plus 3 z square upon z minus 2 into z plus 3. Cancelling z plus 3 from numerator and denominator, we get limit z tends to negative 3 applied on z square upon z minus 2 which gives us negative 9 by 5 as the residue. By residue theorem, we have integral over c f of z dz equals 2 pi I times sum of residues. Therefore, 2 pi I times 4 by 5 plus negative 9 by 5. Thus, we obtain residue sum as negative 1. Therefore, integral over c f of z dz equals negative 1 into 2 pi I which is negative 2 pi I.